All right, so here's what I would like you to do right now. I'm going to do a little right brain stuff for just a second. I want you to, on your table in front of you there's a hat, okay? Each of you has a hat in front of you, okay? I want you to write on this hat. Just take your pen, your invisible pen, and I want you to write. Come on, do it with me. Do it with me. I want you to write thinking on this hat. Okay, write it on there, just cursive, block letters, stencil, however you want to do it, right? Thinking. Now I want you to pick it up, and I want you to put it on your head. Let it rest there and feel the energy starting to take place. Feel the dendrites and your neurons starting to connect together. And I want you to kind of allow yourself to well, let's start with this cute little... Does everyone know who Stephen Hawking is? Does anyone know who's Stephen Hawking? Anybody?
He's the guy in the wheelchair that he invented the textbook talk stuff.
Oh, did he invent that? I don't know.
I think so. Like, that's what I believe. I know he was in the wheelchair and he couldn't talk or anything, so he invented that little textbook.
Super brilliant guy. One of the greatest scientists, one of the greatest minds of all time. Well, he wrote a book called, oh man, what was the name of the book? A Brief History of Time? I forgot what the name of the book was. I have it. And he said this in the beginning. We're going to read this together. He said this in the beginning of his book. He said, an elderly lady confronted Bertrand Russell at the end of his lecture on orbiting planets. Bertrand Russell, a scientist, on his lecture on orbiting planets, saying, what you've told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise. Russell gave a superior smile before asking what the turtle was standing on. You're very clever, young man, very clever, replied the old woman, but it's turtles all the way down. What's the point of that? What's he trying to say there? Huh? What's he trying to say? It's turtles all the way down. Get that picture in your... So the world is a flat plate sitting on the turtles, on a turtle. That's how she perceived reality, right? And then he said, what's the turtle sit on? It's turtles all the way down. What's the point? This is the most brilliant guy. This is the first thing he puts in his book. You didn't argue with her? No.
It'll be round. She loves her. It would be flat.
No.
Maybe I should have talked through this. Maybe I should
I think what he's trying to say is, it's like a saying,
which means it's not flat.
the same opinion still. No matter what you do to try and...
Man convinced against his will is of the same opinion still?
Yes,
Okay.
no matter what, if somebody wants to believe something, they will find whatever rational excuse to believe it, even if they have to invent it, which is standing on another triple.
Do you guys hear that? What are you saying? Did you get that? Okay, that's the right direction. So say it again. Go ahead, Sam.
Which part?
The last three sentences. After the man convinced of his... how did that go? Man? Say that again.
Man convinced against his will is of the same opinion still.
Okay. So then what did you say?
So that if you have an ingrained belief, you'll find whatever irrational support to support that belief. Even
Yeah.
if that means you have to invent a turtle standing on another turtle.
Yeah. For how many years was the world flat? And all the scientific, Galileo came along and they said, you're crazy. All the things that you're telling us, we're going to kill you because of the things that you're telling us are flat wrong. Okay? Now the reason why I want to start with this is because What I want to share with you in the next several days, probably will take 2 weeks playing with this idea and the various components of it. The idea, or the hope that I would like you to entertain, the attitude that I'd like you to entertain is one of, I may not be sure of anything here. As a matter of fact, there's an outside chance most everything that I think is right may not be quite so right. Kind of like the flat earth that the people of, before Columbus's time thought the word, no matter what you say, the sun goes around the earth. And no matter what you say, we're still right. Okay? So, some of this stuff is going to seem a little like, oh, jeez, I don't know if I can believe that. I don't want you to believe anything. What I want you to do is take it in and see what works for you and be interested, because this has the potential of being one of the most interesting things you've ever played around with. So, let's start with some hard science. Hard science, okay? Hard science. Somebody tell me what this table's made of. Okay, anybody? What's this table? Hard science. What's this table made of? What do you see? Okay? What is it? Laminate. Okay. Laminate. Okay. At its outermost, what we can feel and touch is laminate, whatever that means. Okay? It's not wood, right? I don't think there's any, there might be a little bit of wood. But, okay, so now, if we took this, what?
Sorry, I was screaming.
There's something there, right? There's something hard. I can't put my, I can't even put a narrow-tipped pen through it, right? I think Sam knows where we're going with this. So, if you took a microscope, just a microscope, and looked at this piece of table, what would you see?
Like atoms?
With a microscope?
I don't know.
Come on, you took 8th grade science. What do you see when you put stuff under a microscope? What would you see? Okay. You might see grain. You might see some bugs floating. There might, and as a matter of fact, there's probably millions of bugs sitting on here. Have you ever seen there was a book that I once got called The Secret House. And this book was so interesting. This has nothing to do with this, but it was so interesting. A guy took a really powerful microscope and went around a house. And he took pictures of every part of the house. It's like a zoo of bugs that are alive all over your house. It was the most weird-looking little bugs are everywhere. Everywhere. Isn't that great?
Yeah, that's as comforting as that billboard that says you eat 6 spiders in your lifetime while you're asleep, and I'm like, that doesn't make me feel good.
No.
7. Or 7, or whatever it is.
Yeah. Same people who calculate how many thoughts you have in a day. Thank heaven we have an immune system. So let's say you go to a more powerful microscope of this table, or you could do your own hand, same thing. What would you see? What is below this? Let's say you go to let's go into our body. Let's make it a little more personal. Okay? So we have the body, and below that we have skin, we have tissues and organs. Okay? Okay, and below that we have cells. And below that we have molecules. And below that we have atoms, right? And what does an atom look like? Okay, so here we have, there's, what are the parts of an atom? Okay, so you have a nucleus made up of protons and neutrons, right? And then you have orbiting, we'll call them orbiting. We have electrons that are, it's not like we think, like the Earth goes around the sun in an even path. That's not how the electrons go, right? They used to think that. That's what they used to teach in 8th grade science. They said, oh, it orbits just like this. Well, it's nothing even close to this. They come in and out. As a matter of fact, well, I'll get to that in a second. They come in and out of existence, but they're flying around. Now, here's an interesting thing. What is two interesting things. What is the distance relative between this nucleus and these orbiting electrons as far as something we can put our finger on that makes sense to us, as far as distance, only it's small? Do you know? Like between here and how far is the distance between this proton and this neutron, this proton and the electrons?
My class, the teacher told me it's like a baseball in the very middle of a stadium. Baseball in the very middle would be like the proton and the neutrons, and the electrons are around the outside of the baseball stadium.
Around the outside of the baseball stadium.
Yeah.
See, I've heard it's as far similarly as the sun and the planets. And I've heard also a speck of dust in a cathedral. I've heard several different ways that people try to describe the distance between here. Now, what's inside here? What's inside there, Mr. Physics?
Inside the protons
Yeah.
and neutrons? That's kind of what they're working on right now, but so far indications are gluons, muons,
Is there a piece on? There's probably a
what's in the gluon?
there's probably a crouton in there somewhere. The muon. What else?
Gluon,
Gluon.
G-L-U-O-N.
Glue on, glue off.
These are what G-L-U-O-N.
So essentially, there's an inside to this, right? Now, here's the question. So this is us, or this is this table that has this huge, the baseball and the stadium. What's in between the baseball and the stadium part? What?
Fans.
Lots of fans. What? Okay, what do you mean, energy?
I guess I think the electrons moving, but it's through a force. I don't know, I just think energy.
Okay, we'll put those two words over here. You said energy, and you said force. Okay. Do you see? I mean, does that? Do you have any concept of that empty space? Do you have any experience of that empty space? Have you ever gone through a wall? Have you ever been able to go put your hand through your other hand? Because this is a lot of space between the nucleus and these orbiting electrons. That's a lot of space. One writer said, our physical body this body of ours is 99.9% empty space. Doesn't feel like it's empty space when I touch myself and I knock myself, and that doesn't feel like empty space. Yet that's what the scientists are telling us, as is every other physical thing, that it is 99% empty space. Okay? And so we call this a nothingness. You know, there's nothing there, right? Wrong. There's something in there, and this is where the scientists, and I'm no brilliant scientist guy, but I'm very interested in this component of it. I'm not nearly as smart as Sam is in understanding the math of physics, you know, and all of that stuff. But I have been studying this kind of direction we're going in for quite some time, and everyone keeps saying the same things who's writing about this. And so there's some consistency among scientists about this. They say that this is essentially, this empty space, this 99%, is a field of something. It's not physical, but it's a field of something. And that is what I want to try to get you to understand with the limited understanding that I have. I want us to play with what this is and why it's so important. You know, you could say, well, big deal. I can't see it. I can't touch it. It's not real. It's not there. I can't experience it. Why should I care? Well, when we start to understand what the people are saying about this field, we start to understand that this is who we are. This field is us. It's not a separate something, but it is entirely who we are as well. Okay? So, what I'd like to do for just a little bit, does anyone have any questions about this? Let me show you this quote. This is from Max. Tell us who, Sam, tell us who Max Planck is. Do you know Max Planck?
Yeah.
Okay, hold on, everyone.
Can I summarize it? I don't know.
Yeah, really, in a nutshell, who's Max Planck? Is he a smart guy?
Yeah. No, he's the one who developed Planck's constant, which is used in almost all nuclear dynamics.
Can you guys hear him? Okay, speak loud.
He's the guy that developed Planck's constant, which is used in a lot of the calculations for quantum physics, electrical physics, nuclear physics, optical physics, pretty much in every realm of physics, his constant comes in.
Okay, really smart guy. He said this. This is one of the, he won a Nobel Prize in science. This is what he said. As a man who has devoted his whole life to the study of the most clear-headed science and the study of matter, I can tell you, as the result of my research about atoms, what we just talked about, there is no matter as such. Whoa. Turtles all the way down suddenly seems plausible. He says, all matter originates and exists only by virtue of a force, thank you, Erica, which brings the particles of an atom to vibration and holds the most minute solar system of the atom together. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter. Now, and just as a sideline note, that's where the movie The Matrix came from, this statement that Max Planck said. The movies, the Keanu Reeves. So I want to introduce you to this. There's actually a book written by Lynn McTaggart. I have several books. We've got several more of these on the book list, and I'm reading 2 more right now, and I'm planning to get, I've found another list of books that are all about this, but this is one of the original ones that I read, called The Field by Lynn McTaggart, and this is what she's talking about, and she's taken this this and several in her other books that she's written from the scientists who are researching this. This is not from the philosophers or the religious, spiritual people. She's not taking it from them. But what's very interesting is what we'll find is what I kind of figured out, and I didn't figure this out, but it became clear that people from all different branches of life, all different disciplines in life, is that still coming in all right? They talk about this field and they give it a different name, but they're essentially talking about the same thing. So for example, if you were, let me make sure I get this right. If you were a philosopher, you would call this field something like infinite intelligence, or you would call it, if you were, Carl Jung called it, do you remember? Close, yeah. Collective unconsciousness. What would Yoda call it? The Force. People who are of the if you are a Taoist, or if you're in Chinese medicine, you would call it Qi, probably Qi energy or universal energy. If you're a Christian, you might call it the Holy Spirit. Light of Christ. God. If you were a Taoist, you would call it the Tao. Some people are now calling it source or source energy. I mean, there's a lot of different names being given to this, what the scientists are calling this unified field. And I want to just kind of play with what some of these characteristics that all of these people are saying are common, or some of the characteristics of this field according to all of these people, all of these different groups. And essentially they're saying the same thing. So, any questions about this to this point? Any questions? And I know this is like, it makes my brain hurt. That's why we have our thinking caps on, because it keeps your brain. What?
I didn't put one on.
Yeah, it's still there. Until you take it off, it's still there. You didn't put a thinking cap on. Teacher.
It wouldn't help today anyways.
Oh, no, it would.
No, I guarantee thinking caps and...
No, it would, because my intention is that it would work, so it would. So let's play for a little bit with what are the characteristics of this field. Does this make sense so far? That we have this empty space of something that is not just nothing. It's not an emptiness. Okay? So let's go through some of these characteristics. I'm going to pull from some books, and I hope I can get them all in here. First of all, So characteristics. I should do a PowerPoint with this. One is, it is everywhere. Let me read from this first book that I brought in. It's called The Tao of Physics. Great, great book. Let's see. Okay, now just listen closely. This is from the scientists. This is from the scientist side of the fence, talking about this field and its omnipresence. Okay, it says, a careful analysis of the process of observation in atomic physics has shown that the subatomic particles have no meaning in isolated entities, but can only be understood as interconnections between the preparation of an experiment and the subsequent measurement. Quantum theory thus reveals a basic oneness of the universe. There is no here and there at the quantum level, at the smallest level. Yeah, it's all, there's not a disconnection anywhere. Okay? It shows that we cannot decompose the world into independently existing smallest units. As we penetrate into matter, nature does not show us any isolated basic building blocks, but rather appears as a complicated web of relations between the various parts of the whole. I once read, somebody said, when an electron vibrates, the universe shakes. Kind of idea. There is no disconnection, and there's no possibility for a disconnection between any part of this field. Let me give you this other one. I think this is it. He says, the field, this is, I don't know if this is Einstein saying this or Fritjof Capra, but he says, the field exists always and everywhere. It can never be removed. It is the carrier of all material phenomenon. It is the void. Okay, so this field, he's saying, this is the void, this emptiness, out of which the proton creates the pi or p mesons. I don't know how to say that even. P? Mesons?
Yeah, I've heard it pronounced so many different
Okay. In other words, it is the place out of which the material emerges from the immaterial. The smallest material bits come from this, not as the field. Okay? Being and fading of particles are merely forms of motion of the field. So, the first characteristic, and we've played with this before, it's omnipresent, or it's omnipresent. It is everywhere. There's no place it is not. Okay? The second interesting thing about this, this is pure energy. Erica mentioned energy. Well, let me give you some idea of what that really means, because until I understood this, or when I first learned about this, it's like, holy cow, there's... So, everyone, what's Einstein's famous... No, his famous equation. Okay, E equals mc squared. Okay, not Sam. Somebody tell me, what does the E stand for? Okay, so we have energy. Okay, in other words, okay, so the immaterial part, which really that's all everything is, the 99.9%, this energy, E is energy. What does M stand for? Mass or matter. Okay. Times, what is C squared? Don't answer.
Isn't it just a constant?
Mm-mm. It is a something that we can kind of relate to. Speed of light. Good. Which is, how fast is the speed of light?
3 times 10 to the 8 meters per second.
Or 186,000 miles per second squared. Okay? If you put that in a calculator, that's a lot of zeros. Times mass, that's how much potential energy is resting in this. Let me just read you a couple fascinating. This comes from the book, The Holographic Universe. I hope I get the right one here. Okay, listen to this. This just knocked my socks off. When I read this, it has stars all around it. Holy cow. When physicists calculate the amount of energy a wave can possess, in other words, not matter, everything is either in wave or matter form. We could show videos upon videos of what that means. But essentially, at this energy state, before it's turned into the electron, or the physical part, he says, when physicists calculate the minimum amount of energy a wave can possess, they find that every cubic centimeter of empty space, so how big is that? Every cubic centimeter, like this much, right?
Yeah.
Close? I always have to check Sam to see if I'm doing this right. Every cubic centimeter of empty space, take this in, contains more energy than the total energy of all the matter in the known universe. That's the equivalent of if you took, I don't remember if it was like a foot or a centimeter, or you could make all the oceans on Earth boil. Come to a boil with the amount of energy that is in this field, in this much space. Think about that for just a second.
So it reduces the potential or the amount of energy it has once it combines to make matter. Is that what it is?
Once matter is
organized.
Yeah, then it's used that energy to become a physical something.
Okay. But before that, that's how much energy it has.
Yeah.
Oh wow.
So when we say it's energy, we're talking about more than we can imagine in any space, but it doesn't play in the same rules as we do even with that. Okay? All right, we're going to finish with that, and we'll come back on Wednesday, and we're going to explore why this matters and how we're involved with this and what effect we can have on this huge amount of energy waiting. So thanks, everyone. Okay, you can take your thinking hats back off. You don't need them for the rest of your day.